Hello, welcome back to Demand and Supply module, the second part of demand. In this part, we will start to look at how changes in other factors besides demand in the demand function changes the demand curve through the demand function itself. Last time through our example, we're looking at a number of different factors in the demand function. For instance, price of beef, price of chicken, or income level of the consumer. So how will these changes shift the demand curve? So from the principles class, we learned that if there's a change in price, what's going to happen on the demand curve is that we see a point sort of shifting up and down along the demand curve. Whereas if any other factor changes, the demand curve is going to shift. And that's exactly what we're going to see here. So for example, if the price of beef increased by 60 cents, then what's going to happen to the demand curve is that it's going to shift to the right. However, by how much is a much harder question to answer. And whether the shift is going to be parallel is really a little bit of a mystery to us, especially in the principles class. So now let's take a look at that and see whether that answer is definitive. So given our particular demand function here, what we see is that if we squint really hard at this function, then as we increase the value for price of beef, let's say, and holding everything else constant, then each time we dial up price of beef by 1 unit, the quantity demanded will increase by 20 units. You can try this by plugging in very specific values for P, PK, and Y, or you can do a subtraction. And every time you only change PB, because then all the values of P, PK, and Y are just going to cancel out because they're not changing at all. Well, another way to think about this, which is more straightforward, is simply to take a derivative of the demand function with respect to PB. Because by the definition of derivative, we're already sort of holding down everything else constant and only varying PB. So as a result, this measure will give us 20. Because again, this is a linear function. If you take derivative of QD with respect to PB and pretending everything else is just a constant because this is a partial derivative, then the result is just 20. The interpretation of this derivative is that every unit increase in PB is going to change QD by 20 units. And the positive sign tells us that the value is going to be increasing as opposed to decreasing, unlike the change coming from the price of processed pork itself on the previous slide. So how much would a 60 cents increase in the price of beef change quantity demanded? Well, it's going to be 0.6 times 20 units. And that will give us 12 units increase in quantity demanded. Now I want to bring your attention to this particular derivative at a slightly deeper level. So one of the questions I felt very curious in the principles class when I took it was that how do I know the shift of the demand curve is parallel? Well, in this context with our particular demand curve here, when we increase PB by 1 unit, QD always increases by 20 units. And that's the same regardless of the value of P, PK, or Y. In other words, it doesn't matter which part of the curve we're looking at. Whatever P level we're looking at along the curve, the shift of quantity demanded coming from 1 unit increase in PB is always going to be 20 units. In other words, it doesn't matter which part of the demand curve you're looking at. When there is a 60 cents increase in the price of beef, the shift or the increase in quantity demanded is always going to be 12 units. Doesn't matter when the price is low or the price is high. It's always the same. And this is why the demand curve always shifts out in a parallel way, at least given the linear demand function. Well, what if the function is no longer linear? Well, then that becomes different. So through the lens of the demand function, what we realize is that it is the function that gives us these properties of the curve. that are very definitive, and they're not coming from the curves per se, but rather coming from the functions underneath the curves. If the function is no longer taking a particular form, then the curve might behave differently. So now we understand a lot better about when the lessons we learn from the curves are general and when they're not, and to what extent they hold. And that clearly is a much more definitive and assuring answer comparing to just looking at the curve and try to figure out how it moves around. So this is another level of benefits coming from the analysis of functions as opposed to graphs themselves. Similarly, we can look at the effect of increases in price of chicken on quantity demanded for processed pork. What would that be? Well, in this context, it's going to just be taking a derivative of QD with respect to PK while holding everything else constant, therefore the partial derivatives. And the result of the derivative is going to be 3. And the interpretation is, again, every unit increase in price of chicken is going to increase quantity demanded for processed pork by 3 units, and the change is positive. Is the result intuitive? Well, yes. Conceivably, beef and chicken are substitutes for processed pork. So you buy one form of protein or the other. As the price of these alternatives increase, they become less attractive. So people then turn to more consumption of processed pork because this option suddenly becomes more appealing. And that's exactly what we'd expect from our economic intuition. And the function carries that out. And in many ways, it gives us a more precise answer in terms of how these different factors would affect the demand of processed pork, not just in direction, but also in magnitude, and also tells us to what extent these intuitions are general. Now, what if there is some change in the average income level of the consumers in this market? Well, similarly, we know the demand curve will shift because Y is a factor other than price itself, right? And you would expect that if Y increases, conceivably people are going to want to buy more in general, and we'll be more specific about that in a second. So in this particular case, again, along similar lines, to do that, we can just take a derivative of the demand function with respect to income level, and the result is 2. And the interpretation is that if there's a 1 unit increase in income level of consumers, quantity demanded is going to increase by 2 units. When people have higher income, they consume more. So in principles class, you might have also come across the notion of normal goods. And the definition of normal goods are just products whose demand increases when people's income level increases, holding everything else constant, of course. So price hasn't changed, your alternatives hasn't really changed, but the only thing has varied around a little bit is the income level of consumers. For example, I suddenly get a tax credit from the government that gives me $600 for the month. Does that increase my demand for certain goods, holding everything else constant? Economists think that for most goods, this should hold true, and this is why we call them normal goods. So just like law of demand, we're able to write down this notion of normal goods in a very succinct way using derivative and the demand function. What it says is just the partial derivative of the demand function with respect to income level should be positive. So we expect when people's income level increases, demand would increase. If this is the case, we would call this product a normal good. We'll come back to this notion and its related definition of inferior goods later on when we talk about elasticities. In principles class, you might have also come across this issue of aggregating demand curves. And the idea is that if you have 2 groups of consumers or 2 different markets, each has a slightly different demand function or demand curve. What if you would want to understand the demand for the combined big group or the entire large region? Turns out what you can do is you can aggregate demand curves by lumping them up horizontally. As a refresher, let's look at this example here. Let's say we have 3 different individual demand curves. Imagine this as demands for 3 different people, 3 different groups, 3 different towns, and we want to aggregate them up into one demand curve that represents all three of them together. So on this graph, we have demand from group A or person A here, demand for B here, and demand curve for C down here. We can take some intuitive interpretation of this graph here. Consumer A or consumer group A has a stronger demand compared to B and C. Demand A started to become positive when the price is relatively high at $10, and it starts to increase even further and further as price decreases. But demand for consumer B or group B only kicks in once the price is lower than $6. And then for group C, they only start buying when the price is lower than 2. So what's the total demand for all three of them combined? Well, the lesson from the principles class is that we can aggregate demand curves horizontally. The intuition is the following. If we think about all three of them together, when the price is at $10 or $8 or $6, then only consumer A is buying. So for prices above $6, because only consumer A is purchasing, so the entire quantity demanded is going to be coming from consumer A. In other words, A's demand is the market's demand. So when the price is $8, the quantity demanded from the entire market is going to just be what consumer A is willing to buy, which is 2 units, because consumer B is buying 0 and consumer C is buying 0 when the price is 8. And similarly, at a price that equal to $6, only consumer A is buying, consumer B is just about to kick in, but the quantity demanded for B is still 0 here. Of course, it's 0 for C, so the market demand is still only 4 units when the price is at $6. But once the price becomes lower than $6, consumer B start to consume. And now the market demand becomes the sum of consumer A's demand and consumer B's demand. In other words, when the price is at $4, for instance, then consumer A is willing to buy 6 units, and consumer B is willing to buy 2 units. Consumer C is still buying 0. So the sum of demand from them is going to be 6 from A and 2 from B, and that gives us 8 units from both of them. When the price lowers further to $2, the same story carries. The demand is only coming from A and B. So the market demand is the sum of quantity demanded from A and B, which is 8 plus 4. That gives us 12 units. And once the price starts to lower below $2, consumer C kicks in. Now, the demand from the entire market becomes the sum of A and B and C. And in particular, when the price is very close to 0, there will be 10 units demand from consumer A, 6 units demand from consumer B, and maybe 1 unit demand from consumer C. We can add them up together, and that gives us 17. So once we have these points, and in particular the points coming from these kinks where the consumer B and C kicks in, we can connect all these dots, and that gives us an aggregated market demand curve. Right, so this is a lesson from the principles class, and we have to go through a lot of thoughts to think about how the demand curve varies, price lowers from top down. And it's a good exercise that builds a lot of intuition. However, sort of operationally, it is very cumbersome. Is there a better way to do this? Well, it turns out it's really straightforward once you're working with functions, because the functions already defines quantity demanded by themselves. So what we need to do is just to add them up together, because each function is just telling us about the quantity demanded from each consumer. So very intuitively, quantity demanded from the entire market is just the sum of quantity demanded from A and B and C. And on the right-hand side, we'll just be using demand functions for all three of them. So it's really, really straightforward. And we're going to see some examples later on. In this particular context, I want to bring up this example of empirical study mentioned in the textbook. And this is Duffy and Dino's empirical work in 2003 that studies business demand curves for broadband internet. Around the year 2000, internet is starting becoming mainstream, and most companies start to invest into getting their companies connected. So this study is very relevant at the time. And the data they use is quarterly survey of US business establishments from the second quarter of 2000 through the first quarter of 2001. A main finding of the paper is that the small and large businesses actually have very different demand for internet services. In particular, smaller establishments are more price sensitive to changes in price. We can illustrate this finding in a particular graph here. Imagine that if we plot the demand curve separately for the small firms and the large firms and then aggregate them together to look at the overall demand for internet services, then the small firms' demand is going to look a lot flatter comparing to the large firms' demands. If we look at them very closely and think harder about it, these slopes will tell us about sensitivity to prices. Well, why is that? Let's focus on this particular price level, 40 cents on the graph. First of all, at this particular price level, the small firms' demand is less than large firms' demand, and that's clearly reasonable. In addition, if you imagine the price of the internet services increased by 1 unit, let's say increased to 41 cents, then the large firms' demand is going to drop because price pushed up, quantity demand is going to fall back. But compare that change to the change along the demand curve of the small firms' demand curve. What you realize, hopefully, is that as the price increase, the change in quantity demanded along the small firms' demand curve is going to be a lot larger comparing to the reduction along this large firms' demand curve, exactly because the small firms' demand is actually flatter. So this is where the demand curves captures the notion that small firms' demand is more sensitive to price changes. So to measure the overall demand for internet services in this market, we can just aggregate these two demand curves horizontally, and that gives us the total demand curve. Now this concludes our examples for demand